Wanted to do a new video for this section because this is really how the majority of your homework will be done. So I want you to focus on the back of your notes right now, where you're looking at these 3 shortcut guidelines for finding limits. And the first one says if the degree of the numerator is less than the degree of the denominator, then the limit of the rational function is 0. And so I want us to go back and look at example number 1. Rather than having to do all the work that we did on example number 1, you can simply look at your numerator and your denominator. So here we are at example number 1. Your numerator and denominator have the numerator degree would be x to the first. So this would be a degree of 1. So try to write that, a degree of 1. And your denominator, that's x to the third, that would have a degree of 3. So the numerator degree is less than the denominator degree. So the limit as x approaches infinity is 0. And all you have to do is write limit equals 0 or L equals 0. You don't have to write down degree 1 or degree 3. I'm just writing that down so you know what I'm talking about. So it really is that easy. You just need to look at the degree, which is given by the power of the highest exponent in both the numerator and the denominator. So let's go back and focus on number 2 here. So for number 2, it says that if the degree of the numerator is equal to, so if it's equal to the degree of the denominator, then the limit is the ratio of the leading coefficients. Now, ratio of the leading coefficients. All right, let's look at example number 2. In example number 2, you had the limit as x goes to infinity, and we have our degrees. So in the numerator, we have a degree of 1 because it's x to the first, and our denominator, we have a degree of 1, again, x to the first. And so the degrees are equal, as it says for guideline number 2. And so the limit is the ratio of the leading coefficients. So in other words, what are the numbers with those x values that we just looked at? And it's a ratio. That means it's a fraction. Well, that would be, in this problem, negative 2/3. Now, I should have pointed out that these are the same answers that we got in the first video doing all of the algebra work that was described. So this is why I'm calling it a shortcut. You do need to memorize these if you're going to use the shortcut, but it is a nice way to avoid having to do a great deal of algebra. And then our final guideline is number 3. So for number 3, it says if the degree of the numerator is greater than, so degree of the numerator greater than the degree of the denominator, then the limit does not exist and may be described using positive or negative infinity. So as we looked at problem number 3, your degree of the numerator was for x squared, so that would be a degree of 2. And then your degree of your denominator, we had x to the first power, and so that was a degree of 1. So the numerator degree greater than the denominator degree, the limit does not exist. but we can describe it by either positive or negative infinity. And since we had a negative over a positive, we have negative infinity. So the limit didn't exist, but the limit was described as negative infinity. So we could have done all of the work just by knowing those three guidelines. And so for your homework, you do not have to show the work that we showed in video 1. You can use the shortcut that we're using in this video. So now I'm going to take the view to just this one page. And I want to be on the second page of your notes here. So those were the three guidelines that we were looking at. And those are the three that you can use on your homework. And let's just practice it one more time from the top. So problem number 1 here, we have the limit as x approaches infinity. We have 5x to the third plus 1 over 10x to the third minus 3x squared plus 7. So we're going to look at their degrees. And for this one, we have a degree of 3, since this is our highest power in the numerator. In the denominator, the highest power, we have x to the third again, so also a degree 3. So if we take a look, when the degrees are equal, that would be, so the numerator degree is equal to that of the denominator, then the limit is the ratio of the leading coefficients. And so if we go scroll back down and look at our problem here, then the limit would equal the ratio of 5 over 10, and that would reduce to 1/2. So L would equal 1/2. If we had to find the horizontal asymptote, it would be Y equals 1/2. All right, now you can also apply this even when you have radicals. It's not really mathematically correct to say the degree, but this idea does work, and so I'm going to let you use it for this shortcut. So we'll think in terms of degree here using fraction exponents. So this has a degree of 3/2 when you look at this exponent, and then your denominator here has a degree of 1/2 because it's the square root of x. So the degree of the numerator is greater than the degree of the denominator. So let's go see. That would be guideline number 3. And so the limit does not exist. So let's take a look at this idea. The limit does not exist, but we can describe it using positive or negative infinity. So remember that when you do a square root, you get plus or minus, but we're approaching positive infinity. So this would be 4 times infinity. That's going to be positive infinity. And so we can say that this limit is positive infinity. So the limit equals infinity because the degree of the numerator was greater than the degree of the denominator. All right, so let's take a look at problem number, or this second statement that says, when evaluating a limit involving a radical as the denominator, you can use the division method as we described in the introductory video. However, you actually can use the shortcut. Just remember that if you're approaching negative infinity, then you want to think about it in terms of the negative branch of the square root. So I'm going to let you cheat just a little bit here and look at this in terms of a degree. This is a degree of 1 for the x. And this, although you're not really allowed to think of these as individual square roots, this is not a true statement. You can correctly think of the degree. So here we have a degree of the square root of x squared. Well, that's going to be a degree of 1. The square root of x squared would equal x. And so that's a degree of 1. Again, that's not how you evaluate it. We're just looking at the degree. So the degrees are equal. And when the degrees are equal, that's number 2, it says that the limit is the ratio of the leading coefficients. So, so we'll have the coefficient in front of the square root would just be a 1. But remember that we're approaching negative infinity. So this is actually in the plus or minus, this would actually be minus. And so we're going to have a ratio of -3 over -1. And that limit then is going to equal 3. And so it would have a horizontal asymptote of y equals 3. So you can do the same method that we did in the introductory video, but it does work out for you to just think of the degree in terms of doing the square root of that highest x exponent. All right, and we have one more situation to look at, and that situation is described down here in part 3. It says, when evaluating a limit involving a radical, treat the expression as a fraction with a denominator of 1 and rationalize the numerator. So plugging in the infinity does not give you a true picture on a radical expression. So we're going to treat it as a fraction, putting your denominator as a 1, and then we're going to rationalize the numerator. So that means we're going to multiply by the conjugate. So 2x plus the square root of 4x squared plus 1. And remember, what you do to the numerator, you have to do to the denominator. So we'll multiply by the conjugate. This is only when you have a radical expression that is not a fraction. So we didn't have a fraction. We need to create one. So this will be the limit as x approaches infinity. And we can multiply together. We'll have 4x squared. And then if we multiply the middle terms, they'll have opposite signs and drop out. But we'll have minus, and then these square roots will drop out. We'll have 4x squared plus 1, but in a parentheses because we have to eventually distribute the minus sign. And then your denominator would still just be the 2x plus the square root of the 4x squared plus 1. And so then we can combine like terms. So if we do this, we'd have the limit. Actually, I'm going to come down here. As x approaches infinity, the 4x squared minus the 4x squared would go away. We'd have -1 over, and then we'd have 2x plus the square root of 4x squared plus 1. And actually, right now we have -1 over, so we have a constant over something with x's in it. So if we plug in infinity, we end up with -1 over infinity. And according to what we had in the introductory video, that equals 0. So this limit equals 0. And if we were looking for a horizontal asymptote, we would have a horizontal asymptote of y equals 0. So this method of multiplying by the conjugate would only need to be done, again, if you have a radical that is not already a fraction. To find out what that horizontal asymptote is, make the expression into a fraction, rationalize your numerator, and see what happens with it. So there you have your video on the practical ways that you can do your homework. So good luck with that, and be sure that you continue to ask questions.